Hi friends, now today again just we update about the Chandrayaan 3. Now it enters into the moon's gravitational field and first a photo was taken by the captured by the Chandrayaan 3 and sent to the ISRO, and ISRO published very gloriously the first picture captured by the Chandrayaan 3. Okay, very soon it will be landed on the moon. This was the update about the Chandrayaan 3, the glorious one fact of our country, India. Now we are going to learn about the thermal phenomena. What happens when heat energy is supplied to a body? What happens when heat energy is supplied to a body? The temperature of the body rises. That is rise of temperature. Number two, the expansion occurs in case of the body. And number three, the change of state of matter. Today we are going to learn this, how much the matter will expand on heating. In our daily life or in our the day-to-day life, we see this, that the matter expands on heating. One practical, one natural fact is the sagging of electric wires in the summer. Sagging of electric wires in the summer is a very common fact of the expansion of the matter. And the another one that we see, the matter is allowed to expand, that is the a small gap is left between the two rails to allow the expansion, that is the due to the heat produced in the summer and the scorching heat, that is the summer, and also the heat produced due to the friction between the wheels and the rails. That's why a small gap is left between the two rails. And also we see that the bimetallic strip is made based on the expansion of the solid. But different solids expand different in amount. So we have to calculate this. Similarly, in case of the liquid, we have to calculate if the expansion occurs. Yes, of course, in case of the liquid, also it expands on heating. And solids, the expansion is the least, and in case of the liquid, the expansion is more than that of the solid, and in gases, the expansion is the most, because the gas molecules are almost free to move. Now we can calculate this expansion coefficient, how much the matter expands on heating. Let us consider the expansion in solid. First we learn the expansion in solid. Expansion in solid. Let us consider a wire of solid wire of length L1. That is the L1 length, that is AB is the wire length L1 at T1 degree centigrade temperature. And when it is heated, after heating, when heat energy is supplied to the wire after heating at T2 degree centigrade temperature, now the length of the wire becomes, that is now AB prime, and we see that the length is now L2. That means length is increased. How much the length is increased? Increasing length, we can calculate this. Increasing length, this is equal delta L, this is equal L2 minus L1, L2 minus L1. Here the T2 greater than T1, the final temperature is greater than the initial temperature as heat energy is supplied. And similarly the rise of temperature will be this will be T, this is equal T2 minus T1. From this we can calculate how much the length of the solid is increased for every 1 degree rise of temperature. Therefore, for 1 degree rise of temperature, every 1 degree or each degree rise of temperature, the length of the wire is increased by for every for every degree rise of temperature, every degree rise of temperature, length is increased by, length is increased by, this is equal L2 minus L1 divided by T2 minus T1, and this happens when the initial length is L1. So we can calculate this for unit initial length, how much the length of the wire is increased again. Therefore this is called the linear expansion coefficient. When we calculate this for unit initial length, for unit initial length, the length of the wire is increased for every 1 degree centigrade temperature. This will be then L2 minus L1 divided by L1 into T2 minus T1. This is called alpha, the linear expansion coefficient. L2 minus L1 by L1 into T2 minus T1. Very simply we can write this delta L by L1 into T. Similarly, all other expansion coefficients can be calculated. But what will be the unit of it? In case of the alpha linear expansion coefficient, that is alpha linear expansion coefficient, linear expansion coefficient. This is equal alpha. That is the increasing length per unit degree rise of temperature for unit initial length. This will be L2 minus L1 by L1 into T2 minus T1. This is called alpha. For length, for surface area, that is called superficial expansion coefficient. That is called, for surface area, if we consider the surface area, for surface area, that is called superficial or surface area expansion coefficient, superficial expansion coefficient, expansion coefficient. This is denoted by beta. This is equal final surface area S2, initial surface area of S1 divided by S1 into T2 minus T1. Okay. Similarly, if we consider the volume, then what happened? For the volume, that will be cubical expansion coefficient or volume expansion coefficient for volume. If we consider the dimension is the volume, then this will be cubical expansion coefficient. Expansion coefficient. This is equal gamma. This is equal V2 minus V1 by V1 into T2 minus T1. Okay. For linear expansion coefficient denoted by alpha, for superficial or surface area expansion coefficient, this is beta, and for the cubical expansion or volume expansion coefficient, this is gamma. That is the formula and the pattern remains same. But what will be the unit of it? Let's see here. In each cases, it is a fractional rise, fractional increase of either length or surface area or the volume for every 1 degree rise of temperature. So in the unit of expansion coefficient, there will be no unit of length or area or volume. Only the unit of temperature remains. So the unit of it, unit of expansion coefficient, unit of whatever the expansion coefficient, either length or surface area or the volume, in each cases unit of expansion coefficient does not have unit of length or unit of area or unit of volume. They cancel each other. That is, in SI, that will be Kelvin inverse. In CGS, this will be degree centigrade inverse. In FPS, this will be degree Fahrenheit inverse. Okay, this is very important for your board exam and it is frequently asked. What happened? One natural fact of the expansion and the formula for the alpha, beta and gamma and the unit, and why the unit of the expansion coefficient does not have unit of length, area or volume. And there will be the another one important question, that is the standard relation between the alpha, beta and gamma. Very frequently asked question in your board exam. Very frequently asked in alternative year. That is the relation. In the next day, in the next class, we will learn this. Just I mention here alpha equal beta by 2 equal gamma by 3. This is the standard relation between alpha, beta and gamma. Okay, today up to this. In the next class we learn another one important part of it, that is frequently asked in your board exam. Okay.